Finally, the declination shaft came up the road. This 68-foot shop fabrication had been built once before, shipped to the site, rejected as inadequate, trucked away, fabricated again, damaged in the shop, repaired, hastily shipped by rail again, and offloaded just one day ahead of the July 1964 threatened rail strike. Had the shaft been further delayed, the job would have had to shut down, or accomplished by welding aluminum in the field. We were fortunate that highly skilled craftsmen and very delicate construction equipment were available to build this component. Now the 180-ton weldment must be raised to add to its diameter and depth, and it must be moved out from under the derricks whose heft was needed on other heavy assemblies. The lift involved a calculated overload on both derricks. The lift was started, then stopped to weigh it with hydraulic jacks. Calculated weights had been correct. The derricks were lifting 20% over their rating. They rested with the load. Nothing gave, so the lift resumed. It was followed up with piles of cribbing blocks, insurance for a while, then continued to the proper elevation without backup blocking. Two steel A-frames mounted on railway trucks to form a single carriage were. Meanwhile, other parts began to arrive by rail from the fabricators' shops. The hub of the yoke was among the first. This piece, which bolts to the north end of the polar shaft, required a special railroad car to bring it from East Pittsburgh to the siding at Bartow, West Virginia. The size of the weldment was dictated by the availability of this car and by clearances which its use would allow in passing through the mountains. The tightest fit encountered was a natural rock tunnel at Droop Mountain. A bend in the tunnel brought this piece less than 3 inches from the rough rock tunnel roof and sides, and by this much the load passed through. As it starts onto the shored and matted bridge at Bartow, it sticks fast. A second truck again attempted to push from behind, but it too was crippled by the resistance of the heavy load. Damage to date? 2 broken tractor axles and 1 front end. After being bogged down for 5 hours, the signal was given to try again. This time, success. It is now possible to start now with 2 pullers, 1 pusher, and the truck crane winching from the top. It is now possible to start erecting the telescope. Years of model practicing by many people have preceded this erection. Some have declared the maneuver impossible. Some have quit to avoid being identified with the attempt. Word is out. The gallery comes to see who wins. The 20-degree point, then a 30-degree angle is reached. The parking lot fills to capacity. "45 degrees, and the complexity of this truss work is really observable for the first time. At 50 degrees, there is a snap at the south pick point. At 55 degrees, the north pick point shifts 2 inches. The structure shudders, but everything holds. By 75 degrees, the tension is considerable. A tape recorder and 2 cameras are covering the job now. The whole back crane begins to flash and sound the overload warning bell. The failure comes quickly. The lift swings down 4 feet and the bottom corner has dug in. A 1 3/8-inch holdback cable to the truck crane has parted. But the derricks hold. The main load lines hold, and the welding holds. There is no damage except to the cable. Under its own power, the telescope starts into zenith position. Once there, the declination drives, brakes, and controls are installed, and the construction job is finished.